Okay, we're back now. That was a mistake. Alright. I meant to try boosting up my bitrate a little bit. I feel like I was watching the VOD and some of the text in KiCad looks pretty bad. And the way I have everything set up in OBS, there's no scaling. It's the native resolution of my window capture. It's like right into OBS. There's no like scaling, so it shouldn't look as crunchy as it did. But we're gonna try today. We're gonna give it a go, dude. No big deal. Okay. Play the intro, bro. Okay. So, where are we at? I have been doing quite a bit of thinking about the way this is all going to come together, because we're getting really close. We're getting super duper 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 really close, right? Which is very cool to have almost made it. So the thing that I keep thinking about is that the way we have everything set up now, the output of the board here, even though they're not in the drawing, they're DC to DC, or excuse me, they're DC barrel jacks. Let me open this big file.
Voices, words.
Yeah, so
Revolution, salvation, music, until distance.
let me open up the electrical CAD to show you that. Oh, wrong project. LOL. Remember when that didn't work last week? Alright. Yeah, so these are these are barrel jacks. You've seen them, you know them, you love them. Yeah. So initially I was like, okay, I don't want to be... Why did I go with these? One, I have used them in designs successfully before, and I quite like this part. I like the it's truly an SMD component. Like these pads are huge on the board. You get a ton of mechanical retention from the big pads. But like the more I've been thinking about it and like actually thinking about installing this whole thing, the more I'm like, man, it's kind of gonna be having just like, these are gonna be facing downward. This is crazy. They're gonna be dangling, bro. Like they're gonna be, the outlet, the wires are gonna be going down this way. Oh, offline. What? The wires are going to be going down towards the rest of the system this way, and I feel like it's going to be too easy to yank them out of the board by accident, right? Like all you have for mechanical retention is like the friction fit of the connector into the jack. And so I've also been thinking about on the PCB. So if we go in here, oh, whoops. Yeah. On the PCB here, like if we have more of the board in this area, like if we have some more board area over here, we can kind of make just like this outside L piece the high voltage zone, or the high current zone rather, which I think makes things a little cleaner too. Because right now we gotta like snake this shit over here. I don't know. So I'm thinking about screw terminals instead of DC barrel jacks. Screw terminals that I would terminate with ferrules, like those wire crimp things. I have a bunch of them. They work moderately okay. Yeah, I'm thinking about it. At least to the point, and I mean, the hard part of the layout is done. Figuring out like the component placement has been the hard part. Yeah. So let me do screw terminal block. Anything big as hell. Yeah, I've used these before. So yeah, I think I have to do it. Also, I've been like, I'm gonna even though I can only have 7 PWM outputs, it probably makes a lot of sense. What was I looking at? Let me pull this up. It makes sense to just have like, I really don't want to like do this project over. I want to be, once this is installed, my hope is that I'm like done. I'm super done. Yes. Motorized damper. This was the thing I was looking at. Here we go. So Lexapam. Something like this. It makes pretty small ones. Yeah, this is pretty small. 24 volts AC? What the fuck? So this is something I've been thinking about in terms of, let me show you. So at the back of the rack, we're kind of getting into it a little bit, but that's okay. This is what it's all about. So the back of the rack is hidden right now. Yes. So you have these holes in the top of the back of the rack. And I'm thinking about venting heat out of these two big ones. Or maybe the two small ones, or maybe some combination of the two. And wanting, I have some exhaust fan. I do. So I have fans here. Or I've been kind of sketching this. So this is the size of a fan that I have purchased, that I have. Rack's going to be incredible. It's fresh fish sandwich, dudes. How are you doing with your business call there? Fresh fish sandwich. You're very nice. What's up, fresh fish sandwich? What, this is stream? Yo, check out my new soundboard edition. I've got a collection of male yells. Can I get NFL? Yes. What? Can I get an NFL? Yeah, the rack's gonna look good when it's done. But I've just been thinking more about trying to get air. I mean, we already have we have two auxiliary outputs already on the PCB for exhaust fans. But I've just been thinking about wanting to vent the heat outside of the room, because I have an AC on that side of the room that's a window or a portable unit that like vents out of a window, and like I already have a vent in the window, so I might as well vent the hot air from the rack outside as well in the summertime. And so I'm like, okay, but occasionally I'm gonna want the heat vented into the room as well, but not all the time. So that's where these things come in. Yeah, damper size. So you can get tiny ones, little 6-inch ones. Big boy and tiny boy. And so this would all be inside the internal to the rack, and there would just be a single tube coming out the top that would be going, it would go to the window. And so this could divert air in those cases. But these are going to need power, is all of this is to say. These are going to need power. So else? Yeah, so this is pretty small. So something like this. I think all this is to say we're going to want some more I/O just on the board to do more stuff like this, I think. Yeah. I'm gonna save this in my notes. So all this is to say, we got to look at adding more I/O to the board as to hopefully avoid running into wanting to add more stuff in the future. I would much rather, much rather spend the money now. I would much rather spend the money now than wish I had added more I/O later. I'd much rather just do it now, to be honest with you. Alright, so what is the biggest terminal block? Let's go down a memory lane. This is a old project. What were the contacts I used? Yeah, this had a bunch of screw terminals. This was nuts. Had a bunch of these resistors that we had to use. God, this thing is such a mess, dude. A beautiful mess, though. And a functional mess. Alright, so what were these screw terminals called? Hmm? Okay. Phoenix contact combination PTA. So let's try that. PTA. Actually, I can probably see. Oh, wait, was that there? Am I stupid? Little materials. Can't even read my own docs. Oh, it doesn't have the footprint. What was this called? Ah, damn. It crashed. No idea why. This is happening a few times now. We're back now. So it looks. Jeez, sorry about that. I look at my like GPU load. It felt GPU-y to me. GPU-Z. It's really not that warm. Whatever. Stream crashed. It happens, I guess. Okay, so we want to figure out what the hell screw terminals these are from this old project. Because these are pretty good, and these definitely have the gauge of wire that I'm thinking for this. Where did I put these files? Ugh, there's no way to be able to find this easily. Yeah. So we can just fit so many more if we use screw terminals. Like these are roughly the same. They're roughly the same shape here. So if I just place this. Is there gonna be... Yes. Yes. So, oh, that's actually wrong. So it's 12. If I do something like this, It is a ton more I/O. I could move the temperature sensors all to this side. Or I could just put the temperature sensors on that terminal block. All right, so let's start thinking about this in SolidWorks. So what I'm thinking generally is, yeah, we want to have like one, yeah, let's think about this. So if we do, we have to clear. Okay, you seeing what I'm seeing? So if we do, oops, I don't really want to lose this. I never can remember how to spell fucking barrel. That's so humiliating. Yeah, I was right. No, I wasn't. It is so funny to not be able to spell on stream. I love it. CPU, KPCB barrel V1. Okay, cool. All right, so I think if we do the connector, the screw terminals to the left on the bottom and then to the right, because remember we're competing with the Ethernet jack on the other side. Plus I don't want to get have wire that way in the rack. So I think that is probably the move. So first thing we can do immediately is bring this in quite a bit. So we can do like 25 millimeters here. Also, we get this mounting hole up here, which is better. So this doesn't have to be 115 millimeters anymore. This can be like 85 probably. Yeah, because how do we want to, I guess we don't even want to do it. I guess if I go, ooh, that could be neat. So if we do, style style spline. Go like this. And then I think we can just do a straight line. So this would be not necessarily a straight line, just a line with a tangent. And join these two. We work the outer length. Doesn't want to do that. So what is it not like here? I guess it's good. What are you building? No Man 43 in the building. I am doing a air intake system for a server rack. Dude, first of all, we gotta gong you up. Welcome to the stream, my brother. So let me show you what we're doing. So a couple of, actually a while ago, I found on the streets of my city a server rack. So yes, I have pictures on the blog. Yeah, so on the street, I found this rack just chilling by a dumpster, and I brought it home, and I've been building out a server, like a server rack full of old fun enterprise computers. And the issue is, though, that beautiful glass door in the front of it doesn't allow for a ton of ventilation. So on the side, there are these like vent holes, like you can see right here, and like here, but I've never, like, they've just been, obviously it didn't come with any of the accessories. So I've been building air intake modules for the rack. And so let me show you where we're at. So we have a ton done. Where is the big model? So there are these, this is the rack as it stands right now. And so we have a ton of these air intake modules. So the idea is, like, they have fans that are sitting here, and then they pull air through the side of the through the side of the chassis, and then there are those air guides which bring the air to the front of the computers which are sitting inside. So that's where we're at. The plan is to use a BeagleBone Black, which is like a embedded Linux computer, to control everything. And so that's what we're working on now, is the electrical side of it. The software is written, so we're just working on the electrical part. And I'm getting to the point where I'm pretty much done. The schematic's done, the hard part of the layout is done, but I'm just trying to make sure everything is going to kind of fit together the way I want. And I also never want to think about this again. Like once it's installed and operating silently, or like operating in the background, and I really don't want to be messing with this again. So I want to make sure that if there's enough features on the board that if I ever do need to touch it again, I don't have to like redesign the whole project. Yeah, so that's what I'm working on. And there's a command. We should link a video. Yeah, so this is what is this? This is a playlist. Yeah, this is a playlist. Oh my god, I'm wearing the same flannel that I'm wearing right now in the other video. That's embarrassing. But there's a playlist. Oh yeah, that links to a playlist with some of the work that's been going on. So yeah, what's up, bro? What's up, Noman 43? All right, so at this point, I'm into this screw terminal idea. Not much. I think the way I want to do this is make these two dimensions right here. What do you want a server for? Just work mostly, honestly. Have you ever heard of home labbing? It's like taking retired enterprise computer stuff and repurposing it for home use, because you can get really, really powerful, very, very fast computers for not that much money that are on the used market. And so I've been amassing that kind of equipment for a while, mostly for work. It's great having like a 52 core server processor as your daily driver. Not a lot of waiting around, which is great. But you need all the equipment to be able to use it. Right, so if we do this, so if the dimension coming off of the connectors is the same, I think that would look a little bit better too. If this dimension and this dimension are the same, let's see how this looks. So we can bring this into also means we get that mounting point too. This is working out. I am happy with this pivot so far. So I think let's not think about these corners for now. And yeah. I'm also going to take this opportunity to give us some more room up around this upper connector. So we are going to you're getting deleted, you're getting deleted, you're getting deleted. Pretty much this whole upper area is going, and we are going to do a projected offset rectangle. So you are now all for construction, and then we're going to offset these. Yes. Offset entities, let's do 2 millimeters. Nice. So now we have more clearance for routing those traces, because back on the PCB, this is what we had before. This was pretty tight up here, like in this corner. I think the rules checker was pretty unhappy with that, so now we have a little bit more room to work with. Okay, so and then down here, obviously, it doesn't really matter. Okay, so this we don't need, this we don't need. You need to redo that little squiggle. 1, 2, 3. I guess we can't use that whole outer edge there because it is too restrictive. So we can do 2, 3. Bang. 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 Oops. You and you. Okay. I guess this is kind of the dimension that I care about. Okay, so maybe I shouldn't think about it like that. Maybe I should. We do have to fully Yeah, let's do it like that. So we're gonna do, so you do have to fully respect this corner. Oh, I just did that totally wrong. Okay, so you do have to fully respect that corner, but just this edge can come in a lot more. I like that. Make these two equal. Boom. Okay. Let's see if we can make these two equal, just for some symmetry. Nice. Okay, and then over here, nice. Okay, so I can definitely come in more. Let's not make these equal. Just looking at that rendered. If we do this, yeah, that's pretty clean. Okay, so we don't need to have this 2 full millimeters. Let's just do 1. Definitely don't need the full 2. Ah! What is this a part of? whatever. All right, so no, man, thank you for the follow, bro. Big deal. 20th follower, dude. 20th freaking follower. Let's get some, we gotta get some positive gongs going, dude.
Show me a move.
Thank you, Beast. Alright, I'm going to stop spinning the design in CAD. Why can I not figure out what this is? What this sketch is, where this bloody sketch is coming from. Alright, we're gonna take this and we are going to bring it into KiCad. Unless... something like this, maybe? If I do... just to try to make it look a little cooler, bro. You know what I'm saying? Fuck. Okay, it kind of looks dumb as hell. Does it? What do we think? Does that little lip right there look stupid? I think it looks stupid. If I go like this. Maybe? I don't know. Cause I kind of like the, let's see it on the whole thing. I don't even have the file open. I don't even have the file open. Okay, let's see what this looks like. Yeah, that looks stupid as fuck. That looks really bad. We have to hit negative sounds.
Betrayal.
This is no good. We're just gonna go with a corner. All right. Oh, I hate it, but it's okay. Does it cost a lot to run an old server? That's a great question. So, that is one of the biggest downsides, definitely. How much does it cost? So the machines that I have in the rack, one of them is a dual socket Xeon. And then I have a backup server, which is a new, more efficient CPU. It costs like, I know that it is about, it's way less than my AC. I'm just thinking about my power bill. My power bill is the most expensive. It almost doubles in the summer because of running the air conditioners in my place. So it's significantly less. It's like a third as much as running an air conditioner 24/7, which is still a lot. But then it really depends on like what you're doing with it. Like I've been doing a ton of AI stuff recently. And that is just like taking GPUs and running them full tilt. But but also like this is like, again, it's makes me money. Like it's work. It's for work stuff. So it kind of costs what it's going to cost. But you should check out, if you're interested, there's Reddit. Home Lab. If you like this kind of stuff, those are your people, the Home Lab dudes. Yeah, and there's a lot of people in the EU, because of the power price increases from like related to the Russia situation. A lot of people have been really concerned about trying to make their home labs a lot more power efficient, so you can definitely do it, and people do it. It's not a super major concern of mine just because of what I'm doing with it. But yeah. So I think it does. It's not nothing. I'd be lying if I said it was nothing, but it's not crazy. And it heats my room. Like it's winter now. It heats my office, which is good. Okay, so I think this looks good enough. I'm gonna bring this, let's bring this into KiCad. Let's bite the bullet. So what I do here to export this is I go File, Save as copy. You can't see this. Whoops. Okay, so now I have that exported. We're going to transfer it into KiCad. What is the IP address of the KiCad box? Okay, now I can go to KiCad. I have my new DXF, so what I'm gonna do, we're just gonna delete the old shit, honestly. Where is the edge.cuts? Edge cuts. We're gonna do tools. Cleanup tracks and vias. No. What is the name of it? It's called global deletion. Edit. Global deletions. Yes. Graphics. Current layer only. Oh, that didn't do anything. Edit. Global deletions. Board outlines. Current layer only. Okay. Nothing. How do I... Okay, let me just hide everything that isn't edge cuts. Hide all layers. Well, that looks pretty cool. We're going to do edge cuts. And we're going to select all and delete! Oh, it contains locked items, so that's why. Override locks. Ah! Okay. Show all layers. Alright. Place. Import. Graphics. Where are you? Of course it doesn't open up the fucking... Definitely don't open the project folder you're in. Okay. How did I do this before? You can align these, but I forget. How to do it, which is bad. All right, that's not aligned. That's not aligned. Don't even play like that's aligned. How does this look? Outside of the rendering artifacts, looks pretty bad. And we definitely need more room. But this guy's gonna go you probably want to just double that distance. So let's go back into SolidWorks and double that distance. No. Okay. File, import, graphics. I think I need to locate my origin to be on that mounting hole. So file, save as DXF. Okay, let's try that. There is a clever way to do this. I just forget how to do it. File, import graphics. This might be the clever way to do it. 0, 0. No. What the fuck are you? Who are you? No. Import graphics. Yeah, that's how you do it. Grid origin. Okay. Right? View, 3D viewer. Guess this does make it more difficult to integrate the fuse. Which I was pretty excited about. Let's clear out all of this crap. I'm also, wait, I'm gonna hide, where is this? What, no, 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 no. Yeah, use your drawings. Alright, so we are just kind of cleaning house on the old circuit. So if I bring this here, let's just get this fuse out of here. And I select, and I bring this up close AF to there. Yeah, I still need a bit more room. And then I think I have plenty of room over here. Yeah, so those don't necessarily need to be equal. Let's see what that looks like.
I'm gonna take it step by step. There is some kind of poison in this.
Yep, okay.
Going step by step, so I'm gonna break on past the border. Going step by step, it feels like there's something in the air. Step by step, as I try to find a new way forward. By step, it feels like there's something in the
Okay.
I found a reason to stay, and then it faded away. And I'm already on my way out. I found a reason to stay.
Oh, I'm on the wrong screen! Fuck! Oh, I've been doing this for like an hour.
Betrayal.
Sorry. So I basically deleted all the other stuff, essentially.
Found a reason to stay, and then it faded.
thinking I want to do so.
I found a reason to stay. I'm gonna take it step by step by step by step. I'm gonna take it step by step by step by step. I'm gonna take it step by step by step by step. I'm gonna take it step. I'm gonna take it step.
Enough thinking about this. So what was this?
Love me,
This guy's 12.
love me, 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 love me,
All right, we gotta make this a little bigger. So let's shrink this side and expand this side. So that means we gotta break this equality.
love me, love me. Love me, love me, love me, love me, love me,
Alright, let's try bringing this into KiCad. File, save as copy. EXF. KiCad 2, export. Top. Output alignment. Whoop. Back into KiCad. File, import, graphics. Okay, grab this. Boom. Ah, I cheated it too much. That is gonna work. Yeah, okay, so even though, wait, let me just really quickly slam these guys. Put them on top of each other. I guess I don't want them all totally up against that header, so I have room to route the traces. But I think generally the two terminal blocks here... Oh, I hit the grid button. Crap. What was it at? No. Maybe? Whatever. I generally think this is gonna work.
The people come together. It makes it feel good.
Yep.
Ain't no fighting, no destroying. It's the music that moves your heart.
Guess we could pack things better. If we move this resistor, how do we get rid of that fat? There it is.
Feeling lonely, don't erase me. Please don't always focus on my flaws. Oh, always say what I've been doing wrong. The sea's changing, I've been tired of waiting. You keep drifting when no one's listening. Mathematic grading,
yeah, that's gonna work too.
cinematic erase me. Problematic hold you. Too much static inside me. Elevation deny me. Cinematic
We can move it a little closer together too.
patience. Used to walk around so terrified. Now I feel like I am more alive. Deep inside me. Don't deny me. Keep it clear, babe.
Yeah, and if we put the labels back, of course, right? Of course, now it makes sense to put the labels back after we just moved all of them. But
The point of always giving up. Keep 'em looping like the echoes. I'm trying to hold you. You wanna let go.
yeah, that's a better pack right there, I think.
Mathematic waiting, elevation lonely. makes me problematic. Hold you, too much static inside me. Elevation, I mean, cinematic, clear, babe. Elevation. Now it's time to take this final ride. Trying to free you from the state of mind. Need some freedom. Tired of screaming. Some liberation. Transformations. You just wanna keep us all alive.
Is there like a regrid button?
One kind.
Use a good origin point.
Need connection.
Any KiCad experts here?
Static. So electric. Too much static. Elevation. Cinematic.
Regrid items KiCad. Nah, it is not. Whatever. Hmm. kind of silently just doing this, which is not what you want to be doing on stream. This is one of the flow statist activities possible, laying out a circuit board. So my apologies to the chat. Okay, so whew, I gotta sit up. Ah, goddamn. Okay. Let's make this more real. So if we go to this schematic, so if we actually commit to this screw terminal thing, it's so small. So, should I still do the power on a barrel jack, I wonder? Edit. Page settings. Height. We gotta get some more room here. 350. Move the cursed block. We need a third one of these too. Hmm. So we would move this dude up here, I guess, and then we would do transform, mirror vertically? No. Transform, mirror horizontally? Yeah. Fuck yeah. Okay, so now we have yep. Is there a bigger screw terminal drawing? Attributes? Screw. Anything bigger? No. I also remember we didn't like the net labels cluttering everything. So let's make sure this ground and flag lines up. So this is the input power section. So this is gonna go do I have the room that I require? Okay, so I'm not gonna have the room, I don't think. Okay, so we could fit 14. But let's save this. So let's bring this in. Update PCB from Schematic. Close. What?
Is this the end? 'Cause I remember this feeling. It's like I can't speak, and then I feel weak.
Grouping. Ungroup items. Lock. Footprint. This thing. Locking. Align distribute. Horizontal center. Align distribute. Vertical center. Boom! Okay, and then you do hide everything. Hide all layers except for edge cuts. Then you select all. Grouping. Group. Now you have that. Okay. Show all layers. Show all layers. No, no. Use your comments. No. Okay. Alright, so now we do this guy. Needs a footprint.
This is the end, and I remember this feeling. Now I can breathe easy, no need to feel sorry. We should move up, we should move on, 'cause there's no coming back.
We could definitely fit 14. Alright, so I guess I have to fucking do this shit. To delete it, place symbol, screw terminal 01x14. Probably honestly fit 16. If we get crazy with it. And this. Boom. Let me just see how that looks. What? Where are you? File, import, update PCB from schematic. No changes applied. Where's J1? What? Errors. Gonna add J12. Ah. This is much bigger. Let's see what this looks like. Nope, this is exactly what I had before.
Turbulent tide, bound by the science that lives on the lips of the
Boom. Okay, so we're gonna have another. So much of my process is just staring at the design and hoping it's gonna stare back. Sadly. Which does happen sometimes. You would think that that doesn't happen. But sometimes the work talks back, bro. This is already a J2, that's why this is freaking out. Yeah. So it should be 10 and 12 probably. Or 12 and 14. Damn! Alright. Yeah, okay. So many of my fucking designs that end up looking like this. It's okay. Okay, so we got some more terminal changing to do here. So 4, 5, and 6 are all gonna go on this block. Yeah, these net label things I do not like officially. Ooh, shit. Four, 5, and 6 are gonna go on this terminal block. I think we can do some cleverness with the high flag here. Yeah, so we can go like this, and then like this.
Before daybreak there were 9, and as it broke there was 1. From moon to sun it goes on.
And then like this.
The winter battle was won. The summer children were born, and so the story
Then like this.
Come woman in your left piece, those we buried with the house keys, so we can feather where the fields are green from here to eternity. Come woman in your own time, far, far, far from the virgin vine, rise up now from the dead leaves. Come
Okay.
oh, she sings a favorite song, laughter, tears, and dreams, it goes and then on.
Alright, so now we're gonna re-import this schematic, update from PCB. Yep.
Someday the grapes will be wine, and someday you will be mine, and so the story goes on and on. Come woman in your left piece, those we buried with the house keys, so we can feather where the
Okay.
Oh, she sings a favorite song. Laughter, tears, and dreams. It goes and then on.
So that'll definitely work over there. So now the temperature. The thermistor inputs are over there. And then I guess we have to... Oop. These fucking headphones suck. Okay, so... Listen to me, man. I sound pissed. I'm not pissed. Alright, so... I guess we then have to see... So these guys don't have pins. I guess this inner area is going to become somewhat of a transistor pile now, which is okay. Because we are paying for the board space. Hide all layers. So then we want to... I actually show all layers. I think it might be worth it to do another... SolidWorks export. I think we do want the two edges there to be parallel, or to have the same size at least. And then sadly, we do have to bring this billet in. Okay, so Oh, I opened the wrong thing. All right, so we just want to export this. Save as DXF. Save. Alright, now we go back over here. KiCad. So then we want to hide all layers, edge cuts, delete, file, import graphics. Okay. Lock this. Show all layers. Whoa. Alright, so let's start working on laying these blocks out down here. I kind of want to try something new. What if I copy this? Okay, so if I do... So if I delete, so let me screenshot this. So I have a screenshot of the KiCad drawing. I think if I delete these, and then I arrange this block like exactly how I want it, and then I pattern it. That might be better. Really like doing it like this. So when you're reading it, all like the manufacturing mode is orthogonal to like use mode, I guess. Wait, does this fit? This is not gonna fit, I don't think. No, okay. I think that's stupid. It's whatever. Okay, so now we can take this grouping group items. What? What are you? Jesus Christ. Grouping. Ungroup items. What the fuck you doing? Grouping, group items. Create array. So you see what I'm doing here? Create array. What I'm trying to do is have exactly the same, like as tight as possible packing, because there's how many of these things? 1, 2, 3, 4, 5. Create some selection, create array. Okay, horizontal count. Oh, whoops. So 5. So this 7. No. Create array. 8. Nope, almost. Create array. Let's do 11. No, it's too much. It's actually probably good. Give us some routing room. Create array, create from selection, create array. 7? Can I fit 7 down in there? No. No. I can fit 6 though. Create from selection. Can't see because of that stupid lock thing. Actually, I guess it's okay. So if we lock this, no, if I just do this, align to right, this, align to left, is it already, it was, and then I go like this, and I do distribute horizontally. How does this look? Oof, it looks clean as shit. Okay, I am very focused. This is an engineering stream, so there's gonna be a lot of this, and I have to get better about talking through just exactly what I'm working on. All right, so I did the batch create for this transistor section. They're actually MOSFETs, my bust. Grouping, ungroup. So the reference is Q3 here. This guy is D2. We have to go through and do all of this now. I really don't know if there is a better way to do it. There probably is in that menu. This is Q4. Grouping. Ungroup items. You are Q4. You are R11.
I'm just feeling celebration tonight. Celebrate, don't wait too late. No, we don't stop. You can't stop. We're gonna celebrate one more time. One more time. One more time. A celebration. You know we're gonna do it right.
You are R12.
Hey, just feeling. Music's got me feeling the need. Yeah. Come on. All right. We're gonna celebrate one more time. Celebrate and dance so free. Music's got me feeling so free. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate.
Oh, you're fucking kidding me. So it's not gonna let me.
Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me feeling so free.
Oh, nice. Okay, we're chilling. Jesus.
One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me
Alright, so now I gotta go back into. Oops. Back into the schematic.
time. Music's got me feeling so free. We're gonna celebrate.
We gotta add,
One more time.
I guess, another transistor. So this will be
Celebrate and dance so free.
Q7.
Music's got me feeling so free. We're gonna celebrate.
Let's get rid of all of this, please.
One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate. Celebrate and dance so free.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What are you doing?
But suddenly, I feel the shining sun. Before I knew it, this dream was all gone. I don't know what to do about this dream and you.
Grouping, ungroup,
I wish this
you, what? Grouping, ungroup, grouping, ungroup, your Q6,
about this dream and you.
and then
We'll make this dream come true.
D10, R20. Ooh. I guess that's okay. Did I just do that wrong? I did. The fuck?
Why don't you play the game? Why don't you play the game?
Ah. Oh man. 13 and 5. Q5 is 4. Okay, so now we got all those components placed exactly the same. All right, so now we have the task of, so first of all,
Work it, make it, do it, makes us harder, better. stronger. More than power, power, never. Ever after work is over. Work it, make it, do it, makes us harder, better, faster, stronger. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over. Work it harder, make it better, do it faster, makes us stronger. More than ever, hour after hour, work is never over.
Okay. Oh. Your boy is asleep right now. No, I'm fine. I'm fine. I'm fine. I'm fine. I'm fine. Alright. So. What the fuck going on over here? Okay, so I don't think I need all of the remainder of the slots here to be GPIO, like active low things. I think a couple of them could be like switches. And then a couple maybe just GPIO. So we have 1, 2, 3, 4, 5, 6, 7. 7 ports. I guess we could make this one longer because these are going to be the temperature sensors anyways. So if we make this 2 or 3 positions longer, I don't think there's reason not to do that. Let's try that. So let's do J13. Let's make it 4 positions longer. Wait, what? Place symbol 1/16. Wow, this is pretty big. Oh, and that is the biggest one. But I mean, we're probably going to be using multiples of a shorter one anyways. Oh, that doesn't fit. So it's going to be 2 14s, which is kind of nice and symmetrical. Is there a 15? I'm gonna try a 15. I actually think I saw that. Yeah, that's a little bit better. Okay. So if we align these two, vertical center. Boom. Okay. Damn, alright, this is kind of hard now. I'm doing a little T-steep, bros. I'm gonna make a little T real quick. Oh. All right, so what else is there to do here? I guess we have to... I want to hear that back and forth sound. We're gonna pause. Oh, I just fucked it all the way up. This one, back and forth. This song is good. You gotta put on... We gotta figure out... we probably want a switch input. A couple of just like straight off the bugle bone outputs. And probably a few more active low MOSFET out deals
They say an end can be a start. Feels like a barbarian still alive. It's like a bad day that never ends. I feel the chaos around me, a thing I don't try to deny. I better learn to accept that there are things in my life I can't control. They say love is nothing but a sore. I don't even know what love is. Too many tears I've
This is the tea for tonight.
so tired of it all. I have no terror, these are spells. Finding out the secret.
This is the tea for tonight. Let me get my setup.
It's a part of my world that's fading away. You know I don't want to be clever, to be being or superior. True like ice, true like fire. Now I know that a breeze coming me away. Now I know there's much more dignity in defeat than a brother's victory. I'm losing my balance on the tightrope. Tell me please, tell me please, tell me please, tell me please. If I ever feel better, need to spend some good
Pardon the other project.
give me your number. When it's all over, I'll let you know. Hang on.
Pardon the other project. Ooh, you can see the water.
They help me go
Actually,
hard times, but I'm feeling enemy. I'm in league with a foe. Blame me for what's happening. I can try, can try, can try, can try. When those hard times
alright.
through, if in this game I missed the goal. Stormy days and over.
Black Jasmine, dude.
At a better cost. I watched all my castles fall. They were made of dust. After all, someday all this mess will make my love. I can wait, I can wait, I can wait, I can wait. If I ever feel better, remind me to spend some good time with you.
Looks like shit. Black Jasmine tea. Looks crazy.
If I ever feel better, remind me to spend some good time with you. You can give me your number. When it's all over, I'll let you know. It's like somebody took my place. I ain't even playing my own game. The rules have changed, well, I didn't know. There are things in my life I can't control. I feel the chaos around me, a thing I don't try to deny. I better learn to accept that there's a part of my life that will go away. Dark is the night, cold is the ground, and the sickle is silent in my heart. There's one that strives a hell to come. I am sure I come through, I don't know how. They say
Tea pet.
can be a start. Feels like a barbarian still alive. I'm losing my balance on the tightrope. Tell me please, tell me please, tell me please, tell me please. If I ever feel better, remind me to spend some good time with you. You can give me
It's just to smell the lid.
when it's all over, I'll let you know. If I ever feel better,
This shit was kicking my ass earlier today. This is very, very
when it's all
caffeine-y. Is that a...
If I ever feel better, remind me to spend some good time with you.
the wide angle?
You can give me your number.
Cheers.
When it's all over, I'll let you know.
Pretty good. Back at it. Kind of a dead spot right here. I don't know. How the fuse is the thing that I'm the fuse is a tough the fuse is very much in the spirit of I would like to build this exactly one time in my entire life. I need to do a fuse. We can make it work. There's got to be an SMD fuse holder I can use. I can put on the back of the board. Damn, I'm already done with that tea. That was good as fuck. Yeah, we gotta put the fuse here. Okay, so let's figure out what we want to do with these pins. This is up to date now. What is it? I'm not hitting the up key. I guess I'll get fucked. All right, so just played this song. The playlist is kind of blown, fellas. We didn't actually play.
They say an end can be a start.
Yeah. Okay, so we want to add basically more of these blocks. So we can do, so 13, 14, 15. So that is up here. Yeah, so it's gonna be harder to cram. It's doable, but we could make these two a switch. So call it 1, 2, 3. 1. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So positive, and then negative, active low, whatever the fuck, positive, negative, I think we'll just have a single pin is just like a GPIO pass-through. So we'll do one more of these. Five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's a little piece of wire in here. Psych, it was merged. We can use our same cluster. Uncertified electrician, dude, just in time. We're doing electrical design right now. Uncertified electrician. What's up, brother? Let me gong you up. Welcome to the stream. We're doing PCB design. Do you know about fuses, my friend? Uncertified electrician. So if I have a lot of the fuses that I'm looking at on DigiKey or whatever are rated for like 230 volts AC, 120 volts AC, and then like 6 amps of current or whatever. Is there a like known formula for going to DC equivalent for the same fuse? Or is that like something that's normally in the data sheet? I am unsure about fuses, Mr. Electrician. Try fused resistors. What's a fused resistor? Fused resistors are like but I kind of want the I want to be able to swap it without desoldering. Are there like socketed fused resistors? I've seen fused resistors in like multimeters and stuff like that. Fusible resistors. Do they have socketed ones? Maybe. No, mostly dang. Okay. That's kind of a later problem. Anyways, have to fit it on the board. What's your fuse requirement? So, I don't really know. So, I'm doing a fan controller design that, let me show you the PCB so far. So this is like a giant air intake fan controller. So the idea is that it's gonna live inside of this server rack. Let me cut to that. So it lives on the PCB slots onto a BeagleBone Black, which is like the embedded Linux Raspberry Pi style of thing. And then this lives inside of a server rack. So the idea is that I have 4 of these air intake modules There's like one on each of the corners, or each of the vent intake things. But this is kind of like the master node. So this guy is responsible for controlling the fan speed of the other. So it's 3 onboard fans and then 12 other fans. What voltage would your controller take? So it's 12. Everything's 12 volts. So the input to the PCB is 12 volts. That's stepped down to 5 volts for the BeagleBone. The logic level is all 5 volts, but the fans are all 12 volts, and the input is going to be 12 volts to like the PCB. So it's basically 12 volts DC is kind of the input range. But the issue is like amps. Yeah, so it's like stall current is I think it's a little over 4 amps, but that's like stall current if every single fan is like jammed at the same time. So that's pretty rare. And then the BeagleBone is supposed to be able to consume 1 amp max. So it's like probably if the circuit ever encounters anything over 5 amps, that's pretty bad. At that point, I'd probably want to blow a fuse, I guess. And I've looked, there are tons of 6 amp fuses out there, but they're all rated for super high voltage, and I'm just concerned because I don't really know, or like I just don't really know how. I've used poly fuses and stuff before, but this is new territory for me. So yeah, it's probably 6 amps, 12 volts ish. Yeah. If that makes sense. Pretty like small potatoes. None of the power requirements really aren't that crazy. It's 16 little fans. But I don't know. I want to add a fuse just because like I don't want to, when I build this thing into the chassis. Yeah, I found 12. Yeah, see, that's what I keep seeing. Is like, yeah. It's too big. I think I might have to go the fuse resistor out because I think my power draw is too, like if I'm drawing 17 amps, like I have I'm doing N channel MOSFET control for the fans. If I'm drawing 17 amps, it's over for that MOSFET. It's already it's gonna be fried. So yeah. Alright, so this last port here we're gonna do, or no, this is gonna be like this. Did you add a voltage regulator? Yes, I did. So he'll probably do a lot of the protection. It's AZ117. Let me link you to the data sheet. This guy. This dude. So he's the input 12 volts to the system 5 volts for the embedded Linux board. Right here. So I got a fuse here. So it's the fuse app, like the input to the whole thing. But I just haven't. I just gotta do some more research. I gotta do what you're probably doing right now is Google. I gotta do some Googling, some heavy Googling. but I'm gonna do that last because I'm gonna be able to put the fuse probably on the back of the board anyways. So it doesn't really matter too much. But I think the voltage regulator probably has like thermal protection. I mean, all of them say they do, right? But that's probably fine. I was originally going to use a I got several component shops in my town. Damn, you have multiple electronics component shops in your town? That's fantastic. That's very lucky. That's an interesting... Yeah, I'm Mr. DigiKey, dude. That's awesome. We got like hardware stores and stuff near me, but nothing like a Radio Shack. That kind of stuff's all gone where I'm at. Yeah. All right, so this is going to be the yeah, we gotta start labeling these. So this is like the switch input. And then we have the generic. So I'm gonna call it SW0. So the idea here is I could have on the other end of this screw terminal, I could have a switch that when it closes, it shorts the input to ground. So we look for active low. So that could be for, I have no idea. I'm just trying to cram. At this point, we're just trying to put trying to fill up the available board space, and again, thematically, trying to not touch this project. Trying to do this, get it made, manufacture it, or assemble it, and then hopefully not think about this ever again. So we're just gonna call this active low 0. Or maybe NMOS 0. Yeah, let's do that. All right, so I can compact this. This circuit diagram.
And now,
is getting pretty big. Yeah. Which is fine. But it's a little complicated at this point. Trying to make sure these are aligned. Or at least look aligned. Yeah, this is a little hard to see. I'm gonna move these three. US don't shops. US don't have shops that sell components offline like a store. We used to. There are still kind of places. I live in the middle of nowhere, USA. There's definitely none near me. I have no idea about US. You live in India. Nice, brother. Shout out to India. They do have some stuff, but it's like more oriented towards like if you're an electrician, like you can go buy stuff. It's a lot of it's like oriented towards people trying to fix houses and stuff like that, but not like go buy resistors and LEDs and like little individual components, that kind of stuff. We don't have that anymore, which is sad. That's awesome, bro. You're in India? What time is it where you're at? Alright. Dang. Good morning, brother. It is 10:22 p.m. here in the evening. All right, so I guess we have to pick GPIOs for these parts. Actually, let's bring them onto the board. So yeah. That's awesome. You can get SMD stuff in the store. That's so cool. I'm jealous. They used to have a store like that here called Radio Shack, and that was all over the US. Those were all over the place. Radio Shack, no more though. Alright, we're gonna do that technique I did before. With doing the array. So how many do I need? Three. So create from selection, create array. 1, 3, 12, 0. No, that's not enough. Create from selection. Dr. Phil got deporting people. Yeah, I don't know what's going on with that dude. Dr. Phil deporting people, that would be hilarious. I can't believe he still has a show. That guy has been that dude's had a show since like before I was born. Alright, 13.5 looks pretty good. Alright, we're gonna call it like this. Move these over here. Eh. I got that fourth one right there too. I think I'll probably do... Ooh, you know what? I can do 2x2 grid. I can do... create array. Oops. 2x2. And this is gonna be 11. Fuck yeah. Alright, so now we can go like this. And ooh, how do we have see this place called Cody? It's like an electronics hub. Man, that's so sick. I don't know why we don't have that kind of stuff here. I would like live there. Although, I know I have no money. So I guess if I go like this, like space these, I keep the same component pattern. Yeah. I think this is gonna be good enough. Kind of JBC knockoff there, like a speaker, awesome. Is that what you mean? JB. Oh, a soldering iron. Oh, I got the Heika. Yeah, JBC soldering iron. Nice. Are you working on any project, anything cool? Do you have anything online I could check out? Not really. It's all good. Let's lock these two. Why is it not showing that it's locked? Okay, there we go. Go. You. Align. Distribute vertically. Skip locked items. Okay, that didn't work. Line, distribute vertically. Still a student. Cool. You studying electronics? Yeah, electronics and communication systems. Bro, let me give you some gongs for that. That's mega gong. That's awesome. I did electrical engineering, electrical and computer engineering, which seems kind of similar to yours. Good balance between hardware and software is very important. Definitely though, if you do get up to personal projects, etc., take some pictures. Make yourself a little blog. Only top universities would teach stuff like CAD and other practical stuff. It's honestly pretty easy. CAD's the kind of thing, so they didn't teach us any CAD in school where I went to school. There was a little bit of on the simulation side, like the Spice stuff, LT Spice. And then there was a little bit of like project-based stuff. It's actually surprisingly easy to learn CAD stuff. The theory stuff is very hard to learn on the job. I forgot and have to reteach myself the theory stuff constantly. Just by virtue of just like not, it's the kind of thing when you're on the job and you're like working through projects, the design element is like pretty quick. And a lot of the times you're, I don't know, you're like using a lot of, like you're using off the shelf components. So a lot of the hard stuff is kind of like done for you. This is broad stroke generalization, but the theory stuff, it should have entered my mind better, but you know how it is. All right, how does this look? It looks okay. KiCad's pretty easy to learn. This program, and it is $0. It is free. It is fabulous. SolidWorks though, the mechanical CAD program I use, that was not free. That was expensive. That was $6,000. That was too much money. BMS Maintenance Company. BMS Maintenance. Building management systems. Nice, bro. That's great. That's all like PLCs, right? All of the HVAC, HVAC, and access control stuff. That's usually PLCs, right? That's great. They gave me whack jobs to do. No, bro. No, not whack jobs. Damn. That's kind of intern life, though, man. That's kind of intern life. You gotta put it on the resume, though. Clean lithium batteries. Ugh. It is whack. Physical labor. No. Oh, dude. God damn. That is okay, that does sound busted. I won't lie. I wasn't there, so I don't know, but it does sound busted. That sucks. Okay. I feel like there's nothing in the middle of the board, but I think that's fine. I could put the regulator there, but that's gonna make routing everything else really hard. Maybe an empty middle is fine. There's no processor. Maybe I could do a cutout, a cool cutout. All right, let's actually make these the right set of items. So put you over here, put you over here. So this is Q1. R8 and D6. Grouped items, group items, ungroup. Payment under a contractor company, huh? D6. R8. So you had the internship with the contractor who got the BMS job, I understand. Cell balancing. That is cool though. See, it is annoying, but it is kind of cool. Would I want to balance cells all day? No. But it is cool to see that. You read about that stuff in textbooks and you see it in your charge controllers and you're working with batteries, but then to have to actually go do it and see like, wow, why was this one all weird? That's cool. It is cool. Not all summer, or whatever, however long you did it. U10, R27, D13. Oh my god. U10. R27, D13. Chinese is also brutal. Having to read Chinese batteries. That does sound less than ideal. This is D12, Q9, R26. Grouping, ungroup, D12, Q9. The machine sound like a jet engine. No, bro.
Betrayal.
Brutal. The balancing machines or the machines that they were like attached to? The good heaters in the winter, yeah. U8. E11. R 21. Okay. The balancing machines, yeah. Let me see what let me try to find a picture of one of these. I literally do not have any idea. So lithium battery cell balancing machine loud. Is it one of these? Ooh, it looks like it's one of these. Yes, it's in Chinese! Is this it? Oh, go back. Open image in new tab. Now they're like huge servers. Oh, wow. Damn, this shit is crazy as shit. So much power. I would electrocute myself immediately by accident. I would immediately become barbecue. Sadly. Yo, thank you for the follow, by the way, my friend. Okay, so now we have the correct names on these guys. I got a video I can share. I do have Discord. What the hell is my Discord name? Ooh, stream remote enable. That's cool. How do I disable stream remote? What the fuck? Can't even find my name. I am a boomer. I don't know how to use Discord except to play Apex Legends with the fellas. Copy username. Don't I need numbers though? Like normally there's numbers. Whatever. No result. God damn it. Uh-oh. Ah! Whoops. What did I just do? Why is my board transparent? Oh, I must have hit something. Shit. Alright, let me try you. That's my username. Alright. Boom. I sent you a friend request, I think. What did I just do here? Alright, there we go. Jeez. Okay, so now update PCB R25. Who is R25? That's bad. R20. Oh yeah, that's this guy. That's not bad. R25 is very happy right there. Oh fuck. Line. Block. You align. Vertical center. Settings, streamer mode, disable streamer mode, goddamn. Alright, I got you on Discord. Swag. Alright, so ooh, I kind of did this in the wrong order. Wait, so that should have been this one. Crap. I am just gonna switch it. here. Is the center one right? Is Q9 right? Yes, it is. So 8 and 10 are wrong. We're gonna go like this. Yoink. This is hacky and gross. But it's allowed. Okay. Boom. Save. Yes. So that's gonna be like this. 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 Alright, cool. Yeah, I think I added you. I think I DM'd you. All right, so I'm gonna regroup these components. I really like having, this is just gonna make soldering it and thinking about it much easier. I don't want them to come out of alignment from each other, relative to each other. But I am gonna move, I'm gonna shift all of these over a bit. Oh no, that's the group. That's not his courtyard. So we can do line to vertical center pretty easily for these little resistors. Yeah. Is it not letting you copy the file? Is it just like not working? Because I have the chat open and I'm not seeing anything. Yeah, uploading it to YouTube unlisted would be good though. That would definitely work. Distribute vertically. Nice, thank you for, dude, I want to see this thing. Thank you for going through the effort. This is gonna be great. Freaking movie time on the stream. Oh, hell yeah. What the f- Holy shit. Can I show, can I play it on the stream? It's ass over. Yeah, okay. Fuck yeah. Look at this fucking crazy shit, boys. What in the hell? I mean, you did that. Yo, you did that instantly. Oh my god. So this is like a whole... Holy mother of fuck. This is a crazy internship. This is a crazy internship. Load cells in that trolley. Bro, this is labor. You got, dude, you kind of got a scam. You kind of got a crazy internship. Dude, look at this room too. Like, no, it's like factory, like mega. It's like mad clandestine vibes. This looks like a Bitcoin farm or something. This is awesome. Thank you for sharing. This is really cool. I bet you're glad to be done with this. Dude, let me hit you with the sub. That's awesome. That's a wild job. Congrats on being done, dude. You did it. You did it. You did the crazy lithium cell battering balancing internship. I bet you got there and you're like, huh, this really doesn't seem too relevant to my future job prospects. It's brutal. All right. We're making good progress here. Did you lie? Wait, how old are you? You're still in university. So 18's about right. Oh, because... So you're saying if you had lied about your age, you would have been able to do cooler stuff because you were young. They had you doing battery charging. Yeah, I'm glad you're done. Alright, we gotta start picking pins for some of these other things. So, is 41 occupied? What is... It is a GPIO. Alright. We got lucky already. Oh, he hit me with the pick. Oh, nice. There we go. I just got the videos and the photos. Oh my god, brother. I just got the videos. Yeah, you sent the pictures. Yeah, that's crazy. So what were the... Wow. So what were the batteries used for? God, yo, that is sketch, bro. Cell tower backup. Okay, cool. Wow, so it was a massive lithium battery array. Wow. That's actually kind of tight that they do it like that. I'm saying the job's bad. I agree with you. The job is crazy. But conceptually, that's kind of cool. Conceptually, I'm into massive battery arrays to back up critical infrastructure. Okay, this is the one I had to fucking run around the whole board. One battery array caught fire, dude. Had to bust out my male scream soundboard for that. One array caught fire? Were you there? Dude. That is brutal. That is unbelievable. Of course it caught fire. Look at all those fucking batteries. That's insane. In my friend's department. Oh my god, brother. That is so wild. That is so crazy. Is your friend okay? Dude, that would be scary, bro. Big ass lithium fire like that. I would be like, yeah, I'm sick the next day. I can't come in. He's okay, good. You seem like a pretty smart guy. I feel like your friend is a pretty smart guy too. And I feel like you guys can handle yourselves in situations that are crazy like that. Alright, so we have to move few signals here. Who's on 46 and 45? He was in the bathroom at the time. Dang, bro. That's crazy. Like, I'm just trying to, come on now. Can't be burning the place down. That's crazy. That's scary. That's a scary day. Alright, so all of GPIO 61, we can use him. Then we kind of got near the PWM 5, which is here. That's not too bad. It's kind of annoying. We can make that work. Two, three, $202.15 per month. Damn, that is not a lot of money, my brother. To risk burning alive in a strange lithium fire. That is not enough cheddar. How long did you work there? They're high amp, low voltage cells. Wow, that is so cool. It's sounds like you don't like it and you weren't into it. From the outside though, it's really cool. Do you know what kind of current they're able to? 3 months. Nice. First drive is dismantling. Alright, so let's swap 2 and 3 on the pins. What's going on with dismantling? Rusty with bloated batteries. Then you gotta take them apart. Put new bats in. Cost power BMS. Damn, there it is. Look at the boys. Look at the battery squad, dude. Tiny ass image. God damn it. Cause powers BMS. Yes, dudes. At the certification ceremony, Quinn Donjian, vice president of CosPower, said that CosPower attaches great importance to the product research and development and constantly improves R&D investment. The first BMS system that passed the functional safety certification in China is a link in the output of innovation research and development results of CosPowers. In the future, we will continue to promote the technical strength and product quality of CosPowers to further improve laying solid foundation for the development of CosPowers. Wow. Shi Jun, general manager of UL Mihuin in Suzhou, said that functional verification, blah 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 blah. Damn. The new models for the old models are bulky. Okay. Earlier in the evening, or morning for you, you said BMS, and I thought building management, sir. Building management, like HVAC and air handling. You're talking battery management. Wow, look at that shit. God damn. That is freaky. That is a lot of power. 280 amp hour in that little thing. Ooh, dude. Wanted to work in the PCB maintenance department, but they didn't let me work in that department. No! Maybe next time. God, I bet the, yeah. Battery management system. Not going there next time. That's right. You've learned your lesson. The insane battery zone. Not going there next time. Lesson learned. Mr. Electrician has learned his lesson. Not going there next time. Absolutely not. We've learned our lesson. Yo! Sensei Pandu, bro. Thank you for the follow. Give me some... Let me hit some soundboard.
Happy feet, wobble,
I gotta take Wombo Combo out of this. It's true dramatic. Thank you for the follow, Sensei. Damn, I'm swagging out. Of course, my man. How goes it? I'm doing good. My senior with an engineering degree would get paid extra. He would double. Wow. He would like double your money. That's crazy. I'm doing good. We're building a air intake system for a server rack. Let me give you the tour. Let me give you the whole spiel. I found a server rack. This server rack on the street last winter. Me and my boy, under the cover of darkness, heisted it. And I got it back to my place. And so I've been kind of, over the last while, moving all my electronics, server equipment, blah, 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 into the rack. And so I know what to find. Yes, I know. Imagine, dude, I was literally out running. I was jogging. This is where I go running, an area near it. And I could see the glint of the glass. I was like, wow, that's a big, beautiful piece of, yes, some IT guys fed up. So it was, so the bottom of it was rusty. Like the, I think it was, there was like a bunch of rust in here. Part of those companies right there dumping it. Yeah, I think so. There was a flood, there was a bunch of flooding in that area. And I think it just like sustained water damage, or like the equipment inside, and they're probably like, we're done. But I was like, get me in there. So I've been migrating all my stuff into this rack in my free time. And currently, but the issue is it gets really hot because that big beautiful glass door doesn't facilitate a lot of airflow, and so I normally leave it cracked. So what I'm working on are air intake modules. Yeah, sell it for scrap. It's someone who did that. Yeah, just an anger grinder, a new paint, you're good. Yeah, right, exactly. Yeah, that was the idea. I didn't even really need to. I honestly, I just kind of am ignoring the rust. I'm not really that particular. Like I can't see it. It's like it's covered in equipment. Like I can't see down into the rusty area. But anyways, I'm working on air intake modules. So these attach to the slots, and yeah, bring in air. These air guides move air up towards from the to the front of the case where the servers are breathing it in. The brains behind the whole thing is a BeagleBone Black, which is like a Raspberry Pi embedded computer thing. It's going to be running a Flask web server. So it's going to host a website that you can go to like change the fan speeds or whatever. Eventually I'm going to do like PID control based on the temperatures in the rack. But to start, it's going to be manual. We're working on so all of the manufacturing, actually I haven't shown this in a second. Yeah, I was just going to ask. Yeah, eventually going to do PID. Eventually going to do PID, but let me show you some of the printed pieces. I've been manufacturing everything over quite a long time. Yeah. So we got like tons of parts. This is like over a kilogram, well over a kilogram. This is like almost 3 kilograms of printed stuff. So manufacturing's pretty much done. I have, what else can I show you? This is one of the tests for the beagle bone. So this is the beagle bone we're actually going to use. These are the fans we're going to use. Yeah, it's coming together. It's been, I think this is stream. I stream Tuesday nights. Or it's Tuesday morning for Mr. Electrician, but stream on Tuesdays, and this is like Tuesday number 10, I think, working through this. But yeah. All right, so let's get back to it. So right now we're doing the circuit board design. The idea is just to have PWM control. I know the red will look so cool in the box, yeah. And I've got the case. The pictures of it are here. I have a red theme going. So I've got like red cables, and I've got like this red server chassis. So there's like a red thing. Yeah. It'll look good. I think it's gonna look good. The whole like doing a stream project is like, it's indulgent. Like, this is an extremely indulgent project to begin with. Like, spending all this time to like develop this custom thing. I'm like, we might as well make it look good too. Might as well make the whole thing look really good. Anyways, what kind of printer is that in the back? I've been debating on splurging and getting one of the new bamboos. So we got two in the back. I have a Prusa Mark IV and a Prusa Mark II. I have two Prusas that I love dearly. Yeah, the Mark II I don't really use. Wait, let me. I actually have a camera inside of the printer, but I'm not printing right now, so it's off. But yeah, I have a Mark II and a Mark IV. Yeah, the Prusas are great. I've never used a bamboo, but the Mark IV, a big thing for me. I'm in an apartment, so it's got to be quiet. I've heard the bamboos are really fast, but they're like screaming loud. And so I wanted it to be quiet, and the Prusas have like a stealth mode. Yeah, the bamboos at our work are super loud. Yeah, and so it's just not. And it's like when I'm printing, if you're okay, yeah, you have a printer or you have experience with it, so you know. Like when you're really printing, it's like you're printing all the time. Like, yeah, here we go. That's the inside of the printer. But yeah, and for me, it's like I just didn't want to be having too loud. But I like it. I like the Mark IV a lot, and I like the Prusa philosophy. I really do. I've broken a bunch of components on my printer over the years, and it's great to be able to repair it easily. Love the camera for the stream. Yeah, it's good. It's great to like wait, let me show you. I have like an intermission screen. So if I'm like printing or whatever and need to take a break, I can just like throw the printer on. But yeah, the printer kind of looks good. All right, so let's get back into this design. What do you do for work? Super rad. Did you just start streaming? Yeah, this is the first set of got back. I was into it. I was doing it like a couple years ago on a different account, but this is my the longest I've been into it habitually. This project has been the first project on stream. Electrical engineer for a med device company. Hell yeah, bro. Let me hit some fucking gongs. Huge, bro. Saw the KiCad. Yeah. Okay, wait. You can help me. So, how should I... So, this is super low stakes. I was doing math on how I want to fuse this. I don't want to use a fusible resistor. I would love to be able to do like a replaceable mechanical fuse, or not mechanical, like one of the glass things, but a lot of the fuses that you can get on like DigiKey or whatever that I've seen have like major, much more. It's like you can get like a 12 volt DC fuse that's like 7 amps, and if my thing's drawing 7 amps, like the BeagleBone has been dead for minutes. What is the best method to do like low current fuses like that are replaceable? Is this, I know like poly fuses, I've worked with poly fuses before, but I would love, in this case, it'd be great to be able to replace it easily without having to like, because the thing is like once this goes into the rack, because I got to take all my stuff out, install all these pieces, put it all back in. Like I feel like I'm not going to be able to get at this, like get at it, and you know, it'd be good to be able to like have something. I have this like fuse holder thing here that I haven't integrated into the design, but it'd be great to be able to have this on the side of the board, and then I don't know, throw a fuse in there if something breaks. I don't know. The whole point is I don't want this to take, or I don't want to be servicing this a lot once it gets in. And I can't even imagine that something's gonna go wrong. But like, you know, I'm wiring it up, I short something out. I don't want to have to be like, oh my god, I gotta take it all apart and replace the things. Every device that I made has inbuilt fuses to the power plug itself. However, you may be able to use a diode for current protection. Oh, that's a really good idea. Interesting. So you would put the diode... Let me show you my circuit. So this is like my main... The power comes in on this pin, goes through the fuse, and then goes out to the regulator. So would you do a diode in series? I think yes. Diode for current protection. Yeah, I'll check that out. I'm gonna make a note. Oh, in parallel. Panel capacitor in parallel with the diode. Do you know what that circuit's called? Something I could Google. Doing I bet on board, yeah. And that's the thing too. That's exactly, I'm in exactly the same place. Like maybe I just get a 12 volt power supply, 12 volt power supply that's fused. I think maybe that actually might be the move. I'm sure they make power bricks to use power bricks. But then you're talking about the current of the power brick, which you probably can. Maybe I could do an inline fuse, like with the power lead. I'm sure that might exist. I just have to do more Googling, which is kind of not what you want to be doing on stream, but okay, anyways. Actually, no, if I have an EE in the chat, I need to ask my questions. Okay, yeah, that's right. We were swapping. NMOS 1. Okay, it looks like we did it, but we didn't update on the board. Nice. Yep, most of the devices I've made just use an off-the-shelf AC to DC power supply. I sent it twice. No, I only see it one time. Yeah, I think I'm probably gonna end up going that direction. Yeah, maybe I should just have. Maybe I should just think more about my regulator. Cause the thing I'm worried about is cooking the beagle bone. Maybe not. Let me get you some links. Brother. Thank you. No, don't worry about it, bro. My Wi-Fi shot itself, LOL. He's back, though. He's back. What kind of connections are you making to the controller? So it's just logic level stuff. So it's just 3.3 volt level logic. Like it's the controller, the beagle bone is connected directly to N-channel MOSFETs that are driving the fans. And the N-channel MOSFETs are all like the beagle bone's logic level. There's a couple of thermistors that I'm adding as well. Yeah, that song is hot in the mix. A couple of thermistors, but again, that's also, yeah. Put in line to ground to protect that guy. Yeah. Nice. Yeah, I'm just trying to make sure. I'm just looking. I mean, the layout for this, the actual routing of the traces is not going to be that hard. Arranging the components, though. There's just a lot of stuff. I have to work with the beagle bone layout. But I do want to set up. Yeah, I think I'm going to do it like this. And unfortunately, we have to do the dirty with this. But that's okay. This is the bad one, though. Okay, for the logic lines, you need some TVS diodes for protection. I use little fuse diodes. Yes, dude. 5.5 TVS diodes. Oh my good golly gosh. Oh, dude. I've shorted a few of my microcontroller PCBAs I made without these. Damn! This is going immediately into the notebook, bro. Humongous. So... Nice, dude. Mega. Thank you. So it's kind of like a flyback diode. Kinda. Diode in series or diode in parallel with load kind of thing. I get it. Nice. Thank you. Alright, so let's figure out this. I think I might just do this on the underside of the board. Yeah. Okay, I'm gonna do little crappy traces to just kind of block off how I want to do this. Yeah, mainly that. Okay, wait, what were the... This is the other... Oh, what? These are over here? Yeah, kind of more like a river path straight to ground if pressure gets too high as flag deads. Ooh. Capacitor 2 gram, inductor of a motor, yeah. Nice. Dude, beautiful metaphor. Let me get some. Excellent prose. Okay, I can be clever here. Looking for some good links to send. Hell yeah. Don't worry, this is kind of fun for me. Yes, it's very fun. Yes. If you think it's fun, I appreciate it endlessly. Don't stress yourself out though. I don't think you are. I think you're chilling. I think you're happy to work on something that isn't work. All right. Glass of Guinness and the vibes are good. Oh my good golly god. I got Guinness Day. I'm getting Guinness tomorrow. That's so funny. Wednesdays, I go to this jazz club near my house that serves Guinness. And I chill. Hell yeah. Cheers to the Guinness, bro. I'm mad jealous of the Guinness time. I think I have to go under the board. Ugh, it's fine. This is not really gonna get used. That's okay. That's a great coincidence, though. Yeah, brother. Ooh, could I actually go? No. Yeah, it's very crowded. It's okay. It's fine to run signal on the back of the board. Dude, cheers, hell yeah. Okay. Alright, this one doesn't have a pin. What the hell is this? Okay, so this is just general. So what GPIOs? All the 42s on this side. Oh no, that's right, because these are... This is all the LCD and stuff like that. So the closest one to this guy. So this is... What do we want to call this? Probably just GPIO. Did you have a lot? Did you have to snag a lot of improvements from DigiKey Ultra Library? Or did you have to make a lot of them? Honestly, I was kind of just picking. None of this stuff is too exotic. In fact, none of it is exotic, kind of by design. So I just used a lot of the standard footprints. Footprints from the manufacturer. Make it a little easier for myself. Alright, so this one we have to route out this way. Yeah, none of the parts are... Nothing needed to be complicated. And so, I didn't have to make any footprints, which is great. Not that that isn't an enjoyable thing. It can be really fun. There was a buck converter. Fair enough, that's what I do too. Haha, one of my bosses. Okay, all of his own improvement. Yeah. We've all been burned. Everyone's been burned by getting boards made and they arrive and it doesn't fit is one of the least satisfactory engineering dilemmas. There was a buck converter that I hadn't used a DC to DC converter that I thought I was gonna use. It's in the video. I did a video. There's a playlist here. Yeah. There was a DC to DC converter module that I designed previously. Actually, let me just show you. Where's my OBS? What the hell? This thing. Which I'm testing right now. But I'm doing this. This is hard to see. Do I have another one? I have an unpopulated one. But this little board that footprint U1 there. It's for this little DC to DC converter, and I'm doing some other. This is not the air intake project. This is another project, but right there. I was planning on using this because I'm using this in a different context, and I don't really use it as a DC to DC converter, more like a inverting or a non-inverting amplifier kind of thing. So I'd never load, like, the load's pretty constant, and the bugle bone the load characteristic is all over the place. Like it draws a ton of current when it boots up, and then like once it gets into steady state, it draws almost nothing. But this is an instance where I did one of the footprints. But anyways, it didn't work. Like it kept shutting off, which is not a situation I've run into in the other application. So it's like, oh my God, like you're trying to like use your own design over, and then you find problems with it in something that's already like kind of exists in the world. It's like, oh geez, that's the process. Yeah. Get this back. Yeah, give it. Yeah, I have it scope. I got the Rigel DS1054. I do have a scope. I think it's something with my geometry, or just like the polygons. I didn't really respect the wait, let me show you this. Let me show you this part. You'll have a chuckle at this strange part. I didn't really respect the suggested layout. And it worked fine when I assembled it. But then like down at lower, where is this thing? PWM FAM driver, here it is. Yeah, it is this footprint. Let me get in here. Schematic. This guy, AP6 3357. Yeah, Ubuntu. Yep. Yeah, this footprint's crazy. Very strange. What the heck? Yes, very strange. It works good though. You can pull 6 amps peak through this little part. It's like the size of a grain of rice. It's pretty cool. Yeah, yeah, I use Ubuntu for KiCad. I have I'm running. Oh, I put the switch there. No, yeah, I know. All right. Yeah, it's great for so my setup is weird. I have like for the different, so I have different virtual machines for basically by discipline. So I have like this is my like KiCad, this is like my primary electrical and simulation VM. So it's just like all of the projects that are KiCad related. Ultimate has it. Oh yeah. Ultimate pleasure of being able to use Ultimate work. I know, dude. I've never been to the Forbidden Garden, dude. I've never had Altium money, sadly. There was a yeah, VM running on Proxmox. So I have VMs for software, VMs for like I've got my different VMs for basically the different like classes of stuff I work with, different types of software. Yeah, this helps managing all the different stuff. And then you get backups, and you get like hourly snapshots, because Proxmox has a bunch of good backups, so you can just roll back very easily the whole machine if you run into problems, which happens all the time. Yeah, that's the idea. It's so the Proxmox host is the big box. Yeah, I showed it on the blog post earlier. It's in the rack right now. That's what this big box is. Used to be a much bigger box. This was another air intake project, or actually exhaust project. It didn't involve custom PCB design. It was just whipping together a basically voltage control fan driver. Yeah. I don't really have a good top-down picture of the new build, but yeah, the server is a beast. The server is a beast. It is very fun to have an extremely fast. It's very, very, very nice to have way too much computer at your disposal. Documentation is phenomenal. It makes me a blog, bro. Thank you so much. Yeah, I love it. It's the best. Blogging is the best. I've had this blog for over 10 years. Since 2012. Years. Don't post that much. Wish I could post more. But every like professional opportunity, every like cool, a lot of stuff when you post and people read your stuff, like it like propagates in the world and stuff happens. Like I've had a lot of cool opportunities come from the blog over the years. Yeah, animated matplotlib. Yeah. Yeah, bro. This thing was awesome. This project was great. Matplotlib is like my bread and butter at my day job. So it's fun to be able to do a little animation stuff for that one. Do I have to consistently look up functions for MATLAB Playboard? Do you have a lot of it down now? At this point, I have all the time series stuff down. Like a lot of the, but I mean, I don't know. I've got so many different like libraries I've written over the years and wrappers that I just use those. A lot of it's just like how you have like your data plot. That's why I asked. Yeah. Yeah. A lot of the pandas connection to matplotlib, it's a little bit clunky, like the way you go from a pandas data frame to a series to something that you can then plot. But if you can do, like, if you can get your data to the format that the designers of the integration had in mind, it's really, really, really good and saves you a ton of headaches. Yeah, plotting data frames. Yes, how to do this as well. Yeah. It's an important skill. Visualization is really important. Yeah. Yeah, we had a great physics PCB on it. Yes, 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 yes. Nice. All right. Honestly, that is hour 5 of the stream. And I think we're at a pretty good stopping point. Sounds like an interesting day job. Yeah, I wish I was. I mean, grass is always greener. I missed electrical engineering. I went to school for ECE and then went into software for day jobbing. Definitely miss this stuff, but yeah, it is a, yeah, you know, it is fun to get into it sometimes. Yeah, so I think I'm pretty satisfied with where this is at right now. Should I do, if I actually can. I can go. Let's throw this into SolidWorks and see if it passes the vibe check. File, export, step, open rack v3, export. Alright, where is that V3? Alright, let's see what this looks like. Import, 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 processing. Don't have a VM for the Windows stuff though. Don't have a SolidWorks VM. Would love that. Would love to get that working. Have not needed to though. Alright, so this is V3. Alright. Oh, good little read from Art of Electronics for diode protection. Oh, bruh. Dude, are you kidding me?
Damn, son, where'd you find this?
Thank you. Dude, you're the man. I owe you a fucking Guinness, bro. What the fuck? Yeah. I have heard of the Art of Electronics. I've heard. I'm aware. Super aware. Need a copy, honestly. I have Kindle. I have the Kindle one. Everyone has it. Yeah, I had the Kindle. I had the e-reader one in college, and never ponied up for the real one, which is funny. It's funny to be totally busted and you have to steal books. It's always on my desk. Damn, dude, I like that. All right. That might be a good purchase. All right. How does this look? Focusing. All right. Oh, of course I hit the wrong mate. That's the playlist. I'm gonna play that last song one more time. We can wrap this up. I think this looks pretty fucking good. Or, okay. Are we making something beautiful here? Is this a piece of art? No. That's not the goal, though. This is kind of a screw terminal monster, which is okay. It's an obese beaglebone cape screw terminal monster. Is it ever gonna get seen by a human being that isn't me or a reader of my blog? I don't think so. You think it's beautiful. Sensei thinks it's beautiful. Yeah. Is this thing gonna solve is this gonna solve my problems? Fucking absolutely. Are we gonna blow some absolute frigid air into the rack with this thing? 1,000,000%. I'll eventually... Does it have the expansion we need to add lights and add other stuff? Yes. Alright. I'm pleased with this aesthetically. I had a earlier... Wait, let me show you the older version. We had hide, unsuppress. Oh, that's gonna brick my whole thing. What the? What? No, that's not what I want. I want this. Yeah. Oh, it doesn't like the fact. Oh, it's named. Alright, you can't. I can't roll back. Whatever. We've gone through a couple of revisions here. Alright, I'm gonna save all. I do want to show you this though. This is worth seeing. Definitely the PID. You can set up a software PID with Python. Yes. Yeah, I think that should be the easy part. At least I'm a software guy, right? I think that should be doable. Let me open this real quick. Oh no, it's here. Frig. This is the previous one. Opening. Wrong window. Yeah, this is the previous version. It had like a bunch of DC barrel jacks on the bottom. We used this guy's Ruby for when we didn't want our pictures at work. Oh my god. PID. Python programming language. Holy. Wow, this is great. ibmech.com. This is also going in the notes. Dude, I owe you a mountain of Guinnesses. This is great. I've implemented PID in Python before, but I'm interested in seeing how this guy did it. The issue though is the issue that's going to be with this system, the server rack, is it's going to be extremely like unstable. So there's going to be a bunch of different unconnected elements. They're going to be heating it. And I don't want to have like crazy oscillations. So that's actually going to be probably pretty good streaming. Added wind-up control. And I turn off to control it. That's nice. Awesome. Damn, dude. All right. Sensei, that's it for me, dude. Have a good rest of your night. Thank you for tuning in. Thank you for the follow. Thank you for interacting. This has been great. I'll be back on Tuesday. I'm here Tuesday nights. Good talking. Thanks for sharing. Of course, bro. Of course. Start a blog. You seem like you have cool experiences. I want to read about them. I'll stop by if you're live on Tuesday. Hell yeah, bro. All right. Peace.